Hey guys, welcome to question MM249 of the Maths Methods Fortify study guide. So in this question it says consider the function f from -2 to infinity where f of x equals 2 log e of x plus 2 plus 1. We need to sketch the graph of y equals f of x on the set of axes below. Label all important features of the graph. Awesome. So when it says important features, we're talking about x and y intercepts and asymptotes, and any endpoints if there are any, which we're not going to have in a log graph anyway, so that's fine. So let's start with our asymptote, okay? Because in a log graph, it should be fairly straightforward to identify where that's going to be. So this little section here tells us where our asymptote is going to be. So x plus 2 gives us an asymptote at x equals -2, okay? So it's sort of like, so if you want to find out where your asymptote is, you just let this little bit here equal 0, and then you solve for x. So that gives us x equals -2, okay? So that means that our asymptote is at x equals -2, which means it's going to be something like this, x equals -2. So we have to make sure that we label that as well. And then we can find our x and y intercepts. Awesome. How do we find our x and y intercepts? By subbing in x equals 0 and y equals 0. So let's do our y intercept first. X equals 0. Which means that which means that f of 0 is equal to 2 log e of 2 plus 1. Now we can't simplify that any further. We do have our calculator, but it didn't ask us to give it in decimal form. So that's actually going to be our final answer. Our x-intercept is when y equals 0, which means that 0 is equal to 2 log e of x plus 2 plus 1. Take away 1 from both sides and then divide by 2 gives us -1 on 2 equals e to the power of, what am I doing? -1 on 2 equals log e of x on x plus 2, which means that e to the power of -1/2 equals x plus 2. E to the power of -1/2 is the same as 1 over root e, and then we get equals x plus 2, which means that x is equal to 1 over root e minus 2. Awesome. These are our x and y intercepts, and we know that our log is a positive log, so it's going to have a general shape like this. What I would actually do is find out where these actually are on your graph, because it can be a little hard to see where on the graph it's actually going to be. So check out what decimal place this is and then use that as a scale for this, but still label it as an exact value. So what you're going to end up with is something that looks like this. Something like that. So this is our 0, 2 log e of 2 plus 1. And this bit here is 1 over root e, take 2, 0. Awesome. So that's pretty much it. So we've labeled our asymptote, we've labeled our two intercepts. We can even label the graph if we want to, but we don't really have to do that. And that's it. So that is our, it is a 3-mark question. So like I've said before, guys, with graphs, they kind of give you 3 marks to start with, and then based on what you don't put in there, they take marks off. So just try and put all these pieces of information in and you'll be fine. All right, let's move on to part B. Part BI is a 2-mark question. So BI, 2-mark question. And we're asked to find the rule for f dash of x, the gradient function, and state its range. So, awesome. Cool. So where do we go with this? We know that f of x is equal to 2 log e of x plus 2 plus 1, and we need to find out f dash of x. So because this is a 2-mark question, we'll get 1 mark for our gradient function and a 2nd mark for our range. You can just do this in your CAS, but the other thing to do is the derivative of a log is equal to this over, the derivative of this over that, and then the 2 as well. So we have 2 times, and then the derivative of x plus 2 is 1 over itself, which is x plus 2. Then this plus 1 just turns to 0, so we get 2 over x plus 2. This is our first mark, and this graph is a hyperbola, but our domain is -2 to infinity, which means it's always going to be above 0, which means that our range is f of x is an element of 0 to infinity. So it's never going to equal 0, because it's never going to flatten out, but that's what our gradient, because, f dash of x. So this range tells us that our gradient is always going to be between 0 and infinity, so always positive, which makes sense because a log graph is always has a positive gradient. It's never going to turn around and go back down. So that's our second mark for our range. Let's move on to part BII. Part BII is a 1 mark question and pretty much follows on from what I was just explaining, which is, well, let's just go over the question. So it says, hence explain why f of x has no stationary points. Awesome. So because this is a hyperbola, it's never going to have, a hyperbola with an asymptote at y equals 0. So this graph actually looks something like this, has an asymptote at x equals -2, something like this, like that, right? So our hyperbola, not including this part because it's from -2 to infinity, but this graph is never going to touch our x-axis, right? Because it's got an asymptote there. So if it never touches the x-axis, that means that our gradient function is never going to equal 0, which means that we're never going to have a stationary point. So that's pretty much all you need to write for that. Basically, there is no point on f of x, on the gradient function where it's 0, so therefore there's no stationary points. Awesome. Let's move on to part C. So part C is a 2 mark question. Cool. And we are asked, if AB is a point on the graph of y equals f of x, show that the equation of the tangent to y equals f of x at x equals a is given by y plus a take 2x take 2 over a plus 2. Actually, let me just write this down. I'm just going to rub out the bottom of this graph just so I can write it here. So we've got y plus a take 2x take 2 over a plus 2 equals 2 log e of a plus 2. Awesome. So we're wanting to get this tangent equation. So in order to find the equation of a tangent, we know that we always need our gradient, our m value, and a point AB, right? So our tangent is equal to our f dash of x, which is 2 over x plus 2, which means that our gradient at x equals a is going to be f dash of a, which is equal to 2 over a plus 2. Awesome. So from here, we know that we need to find, we've got our gradient, which is 2 over a plus 2. We also need to find a point, right? So we know that our x value is a, that's fine. But now we need to find a y value, which is b. So our y value is given by f of a, which is equal to 2 log e of a plus 2 plus 1, which means that our point is a, 2 log e of a plus 2 plus 1. Awesome. So from here, we know that our tangent is equal to y take y1 equals m, x take x1. You've probably seen me do this a million times by now, which means that our y value is 2 log e of a plus 2 minus, or plus 1, sorry, equals 2 over a plus 2 outside of x minus a. Awesome. From here, sweet, we can actually rearrange this to get y is equal to 2x over a plus 2 minus 2a over a plus 2 plus 2 log e of a plus 2 plus 1. So all I've done is multiply both sides by a plus 2, right? I've actually expanded this and then moved that over to the other side. Sorry, my bad. Cool. And then from here, that's actually our first mark. So somewhere around there is our first mark. Just getting to that point. So then we get y equals 2x over a plus 2 take 2a over a plus 2 plus 2 log e of a plus 2 plus a plus 2 over a plus 2. Okay, so we're just changing this 1 into a plus 2 over a plus 2, and you'll see why in a sec. Because at this point, we've got a plus 2, a plus 2, and a plus 2, which means we can join all these together. So we get 2x take 2a plus a plus 2 over a plus 2. And then that plus 2 log e of a plus 2. Awesome. Now from here, we can actually simplify that down to 2x minus a plus 2 over a plus 2 plus 2 log e of a plus 2. Awesome. Now, we want 2 log e of a plus 2 to be by itself, so we're actually going to take that to the other side. So we get y take 2x take a plus 2 over a plus 2 equals 2 log e of a plus 2. But we're not quite at our answer yet because we actually need to have a plus, right? So we've got this y plus, and we can see that this is the negative version of this, which means that this is the same as y plus, and then we make each one of these negative. So we start with our a because that's going to be our positive when we make it negative. Take away 2x, take 2 over a plus 2 equals 2 log e of a plus 2 as required. Awesome. And that's our second mark. So I know that's a lot of working for 2 marks, but that's life. You got to live with it. So that is our final answer for part C. Let's move on to part D. Part D is quite difficult. So don't stress if you didn't get this one because it is quite a hard one. So part D says, find the coordinates of the points on the graph of y equals f of x such that the tangents to the graph at these points intersect at that point there, which is, I'm going to write it down here, 3 log e of 3 minus 4 over 2, 3 log e of 3 minus 1. Awesome. So basically imagine there's 2 tangents on this graph. So let's say here, going up like this, and here. And what we're saying is these 2 tangents intersect at this point here, which is this point here, right? So this point is our intersection point, and we're looking for the points of these tangents, right? So from here and here, these actual coordinates of these points. So we know that the tangent to these graphs pass through this point here, right? And this is our tangent equation, so we can sub in our x and y values for this tangent and find our value of a, right? Or our values of a. So our y value is 3 log e of 3 minus 1, so we get 3 log e of 3 minus 1, so that's our y value, plus a minus 2, x, our x value is this bit here, so 3 log e of 3 minus 4 over 2, minus 2 over a plus 2, and that's equal to, don't really have enough room here, 2 log e of a plus 2, right? That's our first mark. So recognizing that we need to sub in that coordinate into there is our first mark. From here we can solve in CAS, and what we get is a equals 1 and a equals negative 1. That's our second mark, finding these 2 values. So we know that our a is equal to 1 and our a is equal to negative 1. And from here, we actually need to find our coordinates, right? So we know that this is going to be equal to negative 1. I know this isn't to scale, but this was just me just illustrating the point. So these are our 2 x values, because remember, a represents an x value, which means that in order to find our y value, we can simply sub it into our formula, right? Which is this bit here. So f of 1 at this point is equal to 2 log e of 1 plus 2, which is 3, plus 1, and f of negative 1 is equal to 2 log e of negative 1 plus 2, which is 1, plus 1. Log e of 1 is equal to 0, which means that f of negative 1 equals 1. So what that means is the coordinates of these 2 points here, our tangents, are 2 log e of 3 plus 1, and negative 1, 1. That's our third mark. This bit here is the hardest part, just actually recognizing that's what we have to do, but drawing a diagram is going to be the easiest thing for you. So make sure you draw this diagram, and you just got to recognize that the point of intersection is this point here. But apart from that, guys, please hit me up if you have any questions. I know this is a bit of a difficult question, but just let me know and I'll answer anything you fire my way. So thanks so much for watching, and I'll see you in the next video.